Today we're going to learn about the analysis of function 1. So example number 1, given the function fx equals to this one, we are trying to solve these functions and sketch this function by using the concept of a differentiations. So first question asks you to find the x-intercept and y-intercept. So x-intercept happen when fx equals to 0. So fx is going to be this part, and then we make it equals to 0. So after that, we can solve this equation by using your calculator, and then we get the two value of x equals to 0 and x equals to 3. So the x-intercept for this function are x equals to 0 and x equals to 3. So second question asks you to find the y-intercept of f. So y-intercept happen when x equals to 0. So we already have a fx equals to x to power of 3 minus 6x squared plus 9x. So if a x equals to 0, we substitute here 0. And like this one and this one, so we get 0. By using this one, we already know that the x-intercept are x equals to 0 and x equals to 3, while the y-intercept is 0. So second question asks you to find the interval where the f is increasing and decreasing and find the relative extremum. So how to do this? So first of all, we need to find the critical value. So we already know that the critical value happen when f prime of x equals to 0. Given to you this function, then you need to differentiate this one. So we bring over the 3 here, minus by 1, and then bring over the 2 in front, minus by 1, and you differentiate 9x become 9. So this is the first derivative. So in order to find the critical value, we take the first derivative equals to 0, like this. And then we solve this equation by using your calculator. So we will get x equals to 3 and x equals to 1 as our critical values. So in order to find our critical point, we substitute our critical value into the original functions. This is actually the original functions. When x equals to 1, we substitute here 1, 1, 1, and 1, and then we get 4. So the first of the critical point is 1, 4. For the x equals to 3, we do the same thing, and then we should get 0. So based on this one, we already got our two critical points, which are 1, 4 and 3, 0. After that, we need to find where the interval f is increasing and decreasing. What we should do, we take our critical value, and then put it into the interval like this. So how to do that? Then we have a one number line, negative infinity up to infinity, and then we have 1 as our critical value and 3 as our critical value. So this one we can get 1 interval, 1 3 and 3 infinity based on this one. And then we just choose a value that lies in this interval. So negative 1 to 1 we have a 0, 1 to 3 we have 2, let's say we have 1 here and then 3 here. You can choose any numbers between them. So I choose 2. So same thing going on here, we choose 4. Since we are going to use the first derivative test, we need to understand how to use this particular test. So sine of a f prime, we already know that f prime of x is equals to this part. And then we have a 3x squared minus 12x plus by 9. Then we substitute the value that we choose for the test value. 0, you substitute here, you get plus. And then you substitute 2 here, and then you get negative. And then you take the same thing for, you substitute here, you get positive. The positive represent the increasing functions, while the negative represent the decreasing functions. Based on this table, we can do the conclusions. Our minimum point as we can see here, increasing like this. Top point here happening at 1. So this is going to be our maximum point, 1, 4. And then it's going down like this, and despite it's a minimum point happen when x equals to 3. So this is going to be our minimum point. And then we can get the interval of increasing, this one, and then the interval of decreasing, this one. So we already settled question number 2, question B. So question C asks us, find the interval where the function is concave up or concave down, and determine the inflection point if any. So in order to do the concave up concavity test, so we need to differentiate again. So this why we differentiate. This is the normal function. Then we differentiate 3x squared. Then we bring down the power in front. Then minus by 1. Differentiate this one. So you differentiate again here. You should get 6x minus by 12. So inflection value happen when f double prime equals to 0. After you differentiate this one twice, you make it equals to 0. Then we try to solve this one. This is going to be our inflection value. In order to identify our inflection point, we need to take a look of our concavity test. So how to do the concavity test? Since we have a 2 as our inflection value, one number line contain negative infinity up to infinity. So this one is 2. So we have a 2 interval. And then we can choose a test value 0 and 3, and then we substitute into the f double prime of our test value to get the sign of it. So f double prime here is f double prime of x equals to 6x minus by 12. You substitute 0, you should get negative. You substitute 3, you get a positive value. So negative is a concave down, positive is a concave up. Since these signs are changing, so there exists the inflection point. Because of a negative to the positive, and then we exist the inflection point. So how to find the points? In order to find a point, we substitute the value here into the original function. Always remember that in order to find a point, we need to substitute the value into the original functions, and then we get 2. So our 2 is our inflection point. So then you can make a conclusion as the interval of concave up, this one, to up to infinity, and the interval of concave down is negative infinity. So right now we are ready to sketch our graph. So how we are going to sketch our graph? Let me try to do a graph first. So we have a line like this. So we have x, and then we have y. So based on our analysis, we already know that the x-intercept are x equals to 0 and x equals to 3. So x equals to 0 and x equals to 3. We already know that our graph are going to touch these 2 points. And then for y-intercept is 0. Y-intercept is 0. Okay, that one settled already here. And then we are moving on to our first derivative test here. We already know that our minimum point is 30. Minimum point 30. So we write down the 30 here. 30. And it is a minimum. Minimum you write down like this. Minimum. And then we already have a maximum point 1, 4. So 1, 4. Let's say this is 1. This is 4. So we already have a maximum. When maximum you write down like this. Minimum you write down like this. Then you can combine them. Combine them like this. Okay. Then you can label them 0, 0, maximum point, inflection point, minimum point. Okay. Let me try one more example. Example number 2. We want to sketch this one by using the concept of a differentiation. So first of all, the question asks us to find the x-intercept and then y-intercept. So x-intercept happen when fx equals to 0. So we make it these functions equals to 0, and then we try to solve by using our calculator. We get a 3 value of x. This one, and this one. Then we need to find the y-intercept of f. And then y-intercept happen when x equals to 0. So we take x equals to 0, we substitute here, 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 and here. So you get this one. And then we're moving on to second question. Find the interval where the f is increasing and decreasing. Hence, determine the relative extremum of f, if any. So how to do this? And then we differentiate against 1. So how to differentiate? We bring down the power in front, then minus by 1. Then bring down the power, and then minus by 1. This one become negative 12. You differentiate negative 2, you get 0. And then we need to find our critical value. Critical value happen when f prime of x equals to 0. So make it this one equals to 0. Then we solve by using our calculator. We get a 2 value, which are 1 and negative 2. Since we already get our critical value, in order to get our critical point, we have to substitute our critical value, each of our critical value, into our original function. When x equals to 1, then you substitute into this part, you get negative 9. So this is 1 and 9. And then when x equals to negative 2, you substitute into the original function, you get this one. So right now we have a 2 critical points, or also known as the extremum point. We don't know yet which one is minimum, which one is maximum. How to identify? We need to do the first derivative test. So in order to do the first derivative test, we are going to take the value from our critical value, negative infinity up to infinity. So we have a negative 2 and 1. And then we have an interval number 1, interval number 2, interval number 3, as can be written as this one. Okay, then we choose a value between them. So we have a negative 3, we choose a negative 3, this one we choose 0, this one we choose 2. And then we test our value into our first derivative. Our first derivative equals to 6x squared plus 6x minus by 12. So we take negative 3 here, substitute into x here and x here. You get some value of positive value. Take this one, substitute 0 and 0. You get negative 12. So we just take negative. Because the answer is negative 12, we just take negative. And this one you substitute here. You should get positive something. Then you just take the sign. And then we already know that positive sign is increasing, negative sign is decreasing, this one is increasing. So based on this one, we can identify which one is a minimum and or maximum. So you like this going up like this is a maximum value. Maximum value happen when x equals to negative 2. X equals to negative 2. So this is going to be our minimum value. And then we're moving on. The critical point, this is actually our minimum value. This is minimum value and this is maximum value. Okay, then we already know that our increasing interval of increasing, this one, and our decreasing is this one. Okay, then we are ready to sketch do the second derivative test for the interval of a concave up or concave down. So the interval of concave up or concave down, what we should do, we differentiate again. So we differentiate again our function. This is our original function. This is our first derivative. This one is our second derivative. You bring down the power, get to 12x, and then this one is 6. And then we already know that inflection value happen when f double prime equals to 0, and then we get x equals to negative r. We don't know yet whether the inflection point exists or not. We need to do the concavity test. How to do the concavity test? From our inflection value, we need to build up our interval. And let's say this is half, and then we have the interval negative half here, negative half infinity here. Then we get this one. and then we choose a suitable test value, the value that lies in this interval, and then we test for the f double prime. So f double prime of x equals to of 12x plus by 6. Then we take negative 1, we substitute here, we should get negative. And then we take 0, substitute here, you get positive. So use a concave down and concave up. And then we already know that this is negative and positive, so x is the inflection point. How to find the inflection point? We take the inflection value and then we substitute into the original functions here. And then we get 9 over 2. Then negative 1 over 2, and then 9 over 2 is our inflection point. The concave interval of concave up is this one. Concave up is this one. This is okay. Interval of concave up is negative 1 over 2 infinity, and then interval of concave down is negative this one. And then we are ready to sketch our graph like this. So first of all, what we need to do, we need to sketch like this. Let's say we have a function like this, a graph xy, and then we have a 3 values of x here. 3 value of x, 2 lies in the negative region, 1 lies in positive region. We just can do a rough idea. We have a 2 point here, let's say 2 point here, and then 1 point here. Okay. And then from this part, we already know that the maximum point. So maximum point is negative 2, 18. Negative 2, 18. This point is negative 2, 18 here, and then we already know like this. And then our minimum point is 1, negative 9. So 1, negative 9 is this one, 1, negative 9. And then we just can join them up. Join like this. Going down. We can make our graph beautiful. Okay, like this. We already know that we are really touching the y-axis twice, and then going down, and then going up. Then we adjust our point. We adjust our point here. Adjust our point to make it neat. So this is going to be our first point, second point, third point. Okay. Then we level it out like this.